Welcome to the 29th Annual Exhibit of Hydrogen Fuel Cell Technologies. Boy, it's been a long day. This is our last presentation. We say last but not least, last and perhaps most important, we're going to be discussing Blue World Technologies revolutionizing energy by exploring the potential of methanol fuel cells. Up on the stage next is Friis Jensen, who's the co-founder and CCO of Blue World Technologies. Please welcome with me, Mads.
Thank you.
So, good afternoon.
Good afternoon.
Blue World Technologies, give us a synopsis of what you do, where you are.
So we work very dedicated to make a difference and enable e-fuels. And the way we do that is we make a fuel cell system which can convert liquid hydrogen carriers into electricity in a very effective way. So in a sense, we save energy, but more importantly, we make it economically feasible to transfer from fossil fuels to liquid e-fuels, electrofuels.
Okay, now I know your forte is, as we said, methanol fuel cells. This is not a direct methanol fuel cell. It's something different, isn't it?
That's correct. It's a reformed methanol fuel cell. So that means we reform a mixture of water and methanol into hydrogen, and then we consume it directly after in the fuel cell.
Okay, so you already gave it away, basically. We're not talking about the classical hydrocarbon. There's other sources of methanol out there, and you can create it through reforming those nasty hydrocarbons. This involves accessing renewable energy. So do you have a concept of where you get the energy from? This is all about how to store renewable energy and then how to transport renewable energy and then how to apply renewable energy. Can you take us through that equation?
Yeah. So the key is that you have a liquid fuel which is easy to distribute, easy to store, and to bring to the point where you need to use it. So that's the key of it. Now, methanol is primarily today made of fossil sources, but of course we need to transfer into a renewable methanol stream. Similarly to hydrogen, electricity, we need to take known fuels and turn them into a place where we get it from renewable sources. Yeah.
We almost need to be very specific here because there's so many key words that get lost in the conversation here. Renewable energies, largely they're solar panels or wind turbines that create electricity. Of course, electricity is lousy to transport. And in fact, Germany will never produce enough renewable energy to fire up this industrial economy. So we need to store it somehow. And the obvious case, and it's already a burgeoning industry, is the electrolysis industry. So you convert hydrogen to various fuels, and in fact, the conversion is very, very effective. Let's talk about the advantages when we convert it. It's not that easy, is it, to create a supply chain of hydrogen? You have to pressurize it or liquefy it. So what are the advantages of methanol on the transportation side, getting the energy to the consumer, and also on the application side?
So you need to basically look at how can you most effectively get this hydrogen from where you produce it to some consumer that can manage it. What we have seen recently is that in the marine industry, especially the very big ships where batteries is for sure not an option, they have now started to implement methanol as their fuel, to put it in conventional combustion engines and basically sail on methanol instead of marine fuels, fossil derived. So that's sort of a way where you can see a real first application of methanol into a transportation sector or into use as a fuel.
Now, I know there's some engineers out there who have tears in their eyes because what we're doing, of course, is we're using it in a combustion engine, and that may not be the most efficient way to use methanol. Your business is really also fuel cells that run on methanol. Can we talk about the extra efficiency that you get when you don't combust methanol, but in fact use it as a fuel for methanol fuel cells?
Yeah. So the reason we talk so much about methanol and we even talk about using it in a combustion engine is that that's possible today. So this means that at this time, ships running on methanol, vehicles running on methanol is already a reality. So what we do as a company is we can enable a higher conversion efficiency, meaning we save resources and we make it more economically profitable. So basically you can sail your ship from A to B using less fuel, which is substantial in the marine industry, and that is what we do. But the key point here is that it's not it's an evolution of taking a new fuel and using it in existing technology, and what we do is we enhance that by increasing the conversion efficiency of that fuel.
It's so interesting. This is like a pause button. We have facilities that exist, and we cannot simply shut down shop and say any tanker, for example, any ship that runs on a combustion engine is done with the moment we try to convert to renewable energy. Is this an interim solution, though? And what I'm referring to here is literally these ships we need, and we can't overnight simply dream up a new way of transporting all the goods in this international global economy. So we need these ships, and we need to make them run, obviously, on fuels that are e-fuels. Is there also a business case for using the fuel cell technology that you offer in applications that at some point would supplant the use of methanol in combustion engines?
Yeah, it's about looking at today. There's a green premium when you look at using fossil fuels instead of renewable fuels, and somehow we need to close that gap. We also have to accept that transporting with renewable fuels is more, but fundamentally we need to close the gap as much as possible. And one of the ways of doing that is to increase the conversion efficiency. That's all we are doing. That is basically making sure we enable the e-fuels to be turned into electricity much more efficient.
There's a supply side issue whenever we talk about e-fuels, of course. Could you give us an idea of how many e-fuels of various types are available, or how much methanol in the form of an e-fuel is available, and where we want to get by removing the hydrocarbons from the e-fuels?
Yeah. So to give an example, one feeder ship of containers, which is being launched these days from Maersk, it needs maybe in the vicinity of 10 or 20,000 metric tons of methanol per year. One of those facilities being built in Denmark now that converts solar into electricity and then hydrogen, and then it takes carbon from a biogas plant and makes methanol. So you could say that's a very real example of something that's being enabled this year to show how this can be done in large scale. Now that's 35,000 metric tons per year. That's a relatively small plant. What we're looking at is around 8 million metric tons of methanol projects in the pipeline. And it's one of the more, you could say, in my world at least, one of the ways where you can actually enable a lot of methanol and a lot of hydrogen and a lot of renewable production that can displace fossil fuels and thereby decarbonize.
There's a lot of hydrocarbons out there that we're replacing, or at least we intend to replace, with e-fuels. And one of the interesting questions people ask is, okay, so we have methane and natural gas that we can get, well, we used to be able to get from Russia. You can replace that with synthetic gases. On the level of pollution alone, when you operate a vehicle that is using e-fuels, let's say methanol, that is not produced through traditional hydrocarbons, does it burn more cleanly? Is it more environmentally friendly for the people living next door to the operations of these plants?
So on the plant side is one thing. If you're looking at the application side, so when you put methanol through a combustion engine compared to a diesel engine, there's a lot less pollutants. When you do the same thing with a methanol fuel cell, it is negligible amounts that comes out. So you remove the local pollution as well the global pollutions of decarbonization. You still have CO2. So CO2 is a carrier, and that needs to be derived from a renewable source, which is either biological or it will be from direct air capture eventually. that is today not where it needs to be to make sense economically. But I think time will tell if we will get there. But I believe we will.
Well, all of those propositions, though, are carbon neutral, aren't they? Because you're taking carbon that would be in the atmosphere anyway, and binding it with hydrogen to make methanol and then releasing it again. So it is this wonderful cycle. We, a while back, had a methanol fuel cell here in the building, and I remember the struggle we went through to get it up and operational. You have everyone and his brother, all of these engineers saying, oh, what are the standards? You know, are we allowed to operate this inside the building? How much CO2 is going to be exited from this tiny device? Do we have a notion of, well, are there even permits? Are there legal standards that now focus on the safety of methanol, the exhausts proposition of methanol? Do we know how much more clean they are than diesel vehicles so that laws can change to make mobility a potential where it's now forbidden? Because the diesel engines off the coast of some Italian cities, they hate them.
So yes, there is, and it varies from application to application. So marine, this is you could say a recognized fuel, and this can be implemented already now on ships in the marine industry. If you look into land-based transport and automotive, it's clear that in Europe it is not a very widespread fuel. There's not so much experience with it. If you go to the States, there was a lot of experience in the 70s regarding methanol implementation. This all went away when the oil crisis was stopped, so oil again was on the table. In China, for example, there's around 30,000 vehicles today, including 1,000 heavy-duty trucks running on methanol today. So there, where there has been some motivation to implement methanol as a fuel, it has been done over a decade. So all of these kinks in terms of emission regulations, refueling safety standards, the use by normal people in these vehicles, all of that has been well tested and implemented. So we don't know much about it in Europe, but in other places it's well understood.
You just mentioned one case scenario, China in particular, that has an existing infrastructure of methanol. Even if it is not the environmentally pure methanol, the reason for the application, of course, is it's a pile cleaner than using other vehicles, alternative vehicles in city environments where they're facing pollution concerns. Are there other models where there is an existing methanol network? That would be important, of course, because even if it is e-fuels, you need to be able to distribute them. You need an infrastructure that deals with methanol. So are there advantages of using methanol simply because certain countries have the infrastructure and they're used to dealing with that fuel?
Yes, I mean, methanol today is mostly known as a chemical. So this means if you wish to have methanol available, you cannot call your refueling company or your normal gasoline company, you would call your chemical company. So anything that's industrial in nature can manage through that supply chain. The only place where you actually need this very large network rollout is if you look into road-based vehicles. And even that is relatively simple. With our factory in Denmark, we built, together with Circle K, a refueling station on methanol, did all the approval work and so on. And it's very simple, it's very cost effective. So to implement that to a nationwide infrastructure is extremely simple and cheap compared to looking at completely new gaseous hydrogen, liquid hydrogen, even battery charging infrastructure. So seen from an infrastructure and distribution perspective, this is really a simple thing to do.
There's always the interest in the short-term and long-term applications of various technologies. Specifically from your vantage, how do you see, first of all, the short-term prospects? What is your company focused on doing in the short term, I would say for the next 15 years?
Yeah, so 15 years would be, I think, long term. Well,
Okay, let's do the short term.
somewhat. Short term would be this year, maybe. No, but so short term, what we're doing is we're making a smaller fuel cell system fueled by methanol that can replace small diesel engines that are today used widely in industry. So that is what we're replacing on the short term. So this will not save the global decarbonization challenge, but it's a way to start. And since we have to go to zero of everything, that problem also needs to be solved. So that's our starting point. That's where we start, one generator at a time. A little bit more long term, it's in the maritime and it's in the heavy duty road transportation. Specifically in the maritime, we are developing a large megawatt scale system that eventually would replace combustion engines on ships. So that's our focus, and we aim to put these units on ships within the next few years.
With so many spin-off effects that are positive for the environment, even they don't disturb the whales as much. They're quieter. It's a pile of advantages to them. It's very difficult to express in numbers sometimes the advantages of these technologies. I think this has gone under in the conversation we've had a bit. Of course, methanol fuel cells rely on PEM technology. You have a reformer, but it's basically our old friend, the PEM fuel cell that is operating in it. We've been waiting for volume because we know the cost of the PEM cell, which is relatively expensive, is dropping as the volumes increase. Can the industry, the PEM cell industry, keep up with the demand that you envision in the short and long term?
So what we do is high temperature PEM. So it's a special variant of the PEM fuel cell. So we make everything in-house, and we are very dedicated to doing that, because in that manner we also control the scale up. Not that that in any way is easy, but at least we are in control of it. So to give you an example, today we have a capacity in our factory of 15 megawatts of stacks per year. And if you look at the larger container ships, they would need maybe 6 megawatts of capacity for their auxiliary energy needs, right? So it's a few ships per year. So we need to scale up, but there's no question about it. That's a significant task to do that scale up. So that's also why we get started in a place where we can manage it, the smaller systems, but we have a very clear eye on something that would really make a difference and, I wouldn't say save the world, but at least enable e-fuels in the maritime sector so we can get away from using fossil fuels.
And is your business model, this geography is always an interesting question, isn't it? I think it's kind of interesting that the closer one is located to things like shipping facilities, countries with this historical role of being part of the early global economy and now having large ports that facilitate the global industry. Is there a correlation between your geography and your business model?
Not really, but it's convenient, you could say. So clearly, when you want to serve the marine industry, you need to be global, and you need to be able to do something that will make a global impact. But clearly, being in a maritime nation, as Denmark is makes good sense.
I suppose the final question for me is the outlook, the long term. We have a long way to go. We need to upscale the renewable energy equation here, because basically the methanol you want to use is renewable methanol. What initiatives, I think more on the political side, what policies, let's call it, need to be implemented so that this becomes easier? Obviously, if we get lazy and drag our feet and destroy the environment by using fossil fuels, we're going to run into issues of not simply pollution, but global warming. So what policy changes do you see that would aid you, and what initiatives do we need to see in order to make this feasible?
Well, I think it's very much a policy thing, but it is also a matter of the larger companies, which is, you could say, dominating and also to some extent have been responsible for the technologies and the emission of CO2 over the years that has to take a lead and to enable this transition. In terms of policies, my you could say approach to that would be make sure that fossil fuels and more carbonization is eventually stepped out, and then let the industry itself figure out what's the best route. So for example, what we are seeing these days, that you are trying to ban a certain technology or a certain something, that's not the way. You need to ban or put a tax on CO2, and then the industry itself will figure out how do you most cost effectively change into something that's not carbonizing our planet.
It is in the end, isn't it, for a businessman like you, it really is a business proposition, isn't it? It's simple economics. Mads Friis Jensen, who's co-founder and CCO at Blue World Technologies, it's been a pleasure talking to you. I hope you come back next year and tell us how things have gone and keep us in touch with your innovative technologies. We need people like you, of course, to move things forward. So it's been a pleasure talking to you.
Likewise.
Thank you, Mads.
Take care.
And thank you.